Hello.
Hello. My son's going to come in and get an iPad from me. I just heard. He doesn't know that I know that he knows that I know that he knows. Yeah, he needs an iPad, right?
Dun, dun, dun.
She didn't know that I knew, that I heard her, that I know that she knows. This problem's tricky, guys. I've been, since geometry ended, I've been really giving you guys tricky problems. Okay. That's what they said when I was born. Just throw it in the hallway. That was a joke. All right. We're recording, right? I think so. Should have automatically been. See, in this problem, you're going to have to figure out how are you going to get the pieces of information for that formula? A equals.
Wait, didn't we already finish 4-9?
This is 410, yeah. This is it. This is the last section, but this is the warm-up. And the warm-up is a challenge problem from 4-9. So this A equals 2/3 BH, and then B and H are defined by the height of the parabola above flat line B. B is the distance between those points. You have to come to several realizations as you're doing these problems, which is what real problem solving is.
I like this problem.
Yeah. Negative x squared plus 4x, that gives you that upside down one. And letter B there, that's all happening in the negative region. Under the x-axis. A is all occurring above the x-axis. B is occurring below the x-axis. How do I know that? Well, in B, that one opens up. And then that flat line, y is less than or equal to 3, you have to be under that line. Oh, no. Some of it's happening above. I thought that was -3. Okay. So you basically need the components of that formula. You need the B and you need the H. Once you have the B and the H, then you just plug it in. It's 8:30, good morning. So you're trying to find the B and the H. The picture shows you how you define B and H. What I'm trying to do is translate, like we did in geometry. How do you get that to be that, what is that? It's not a green line, or is it? I don't know. How do you get that line to translate down to the x-axis so that that distance they're calling B is the distance between the roots, right? Then you can just solve for the roots, right? So how do you account for that in the math? How does the math account for that line being the root, the x-axis instead of the other one? So that you can bound your area. Okay. So let's just look at the first one then. So let me draw that. Oh, my markers are starting to fail. Let's go get more markers. I'll draw that picture so that we know. when I go to my screen, you'll still have that to look at. Okay, now we'll go to my screen. Make sure you have the letter B copied down. I'm going to stop sharing the screen. By the way, this was available, so you might have this anyway. Okay, so now here we go. You might want to get an idea of what this looks like with a graph if you would like. All right, but how are you going to go about finding this B distance, and how are you going to go about finding this H distance? What are your ideas?
Well, H is
way,
H is the y value of the vertex plus minus the y value of that line.
This horizontal line is where, by the way?
At the x-axis.
This is the x-axis that they're referring to here, y being greater than or equal to 0. Think of it as y equals 0. That's the x-axis. So what we're talking about graphically, you might want to get a picture graphically of what this is looking like. We need everything above that. That's what y is greater than or equal to 0 gives us, is everything above here. We're not considering anything down here. Okay, then if you graph this one, notice there's no C. Okay, so it's not translated up. And it's upside down, negative. So this one's going to look like this. Okay, and it's going to, where's the vertex going to be? Well, it could be at negative b over 2a is one way to do it. So negative 4 over 2a, a is negative 1. So negative 4 over negative 2 is 2. So the vertex here is at 2. Okay. And, oh, wait, no, I can't put 2. And then you plug in 2, and you get 2 squared is 4, negative 4 plus 8 is 4. So at 2, 4. There's your vertex. Now what I might want to do is find my roots. Okay, that's when, if you set this 0, such good practice, guys, you're using all your skills now. 0 is equal to negative x squared plus 4x. Well, I can factor that.
A, the highlighted space is going to be outside the parabola.
Hold on one sec. Let's one thing at a time. I'm going to factor out a negative x, and then I get x minus 4. Okay, so I have x can be 0 or 4. So those are my roots. So 0 and 4. Okay, and so here we go. Here's my graph here. I don't care what happens underneath. I'm looking for this area. Now, where's Surin at? Surin, do you know what to do? Mr. Calculus?
Yeah. Oh, for the area of the parabola.
This is what you would do.
For the area of the region underneath, take the integral. Yeah, definite integral.
From 0 to 4, it's bound at. It's from 0 to 4 of.
Take the definite integral.
Of the function.
Negative x squared plus 4x.
With respect to the change in x.
But of course, you'd have to split it, because if the integral of the sum of two functions is the integral of one function plus the integral of the second, and then you could just take the integral from 0 to 4.
So that you integrate how? This becomes
x cubed over 3, negative x cubed over 3, and the other one becomes 2x squared, because the 4 and the 2 can cancel.
4 squared over 2, which is becomes 2x squared. Okay?
Mm-hmm.
All right. Then you take that from 0 to 4. So when it's 4, you get 4 cubed is negative 64 over 3 plus 4 squared is 16, so 32. What I would do is that's over 1, so times 3, which would be 96. Sorry, everybody. I don't know why I'm going through the integral. This is what? 32 over 3? Okay, so that's, and then when x is 0, then it's 0. So this would be your area, 32 over 3. So it would be 10 and 2/3 is what we're going to get. Now, the integral is how you find the area under a curve from one x value to another.
Yeah.
If I do it to another x value, then I'm going to find the area. I'm going to find a different area. Okay.
Yeah, and if the function happens to go below the x-axis, then the negative and positive area, then the area below the x-axis is going to be registered as negative, and it's going to cancel out with the area above the. It's going to cancel out with the area above the x-axis.
I wonder, you could probably account for that with some absolute value. Okay, so but
Yeah.
they're going to use this formula here. So we now know the b distance here, right? Following what is this distance here is b. So you now know what that is. B is 4, right? And h we now know is 4. Okay, so then you plug it in here. Area is equal to 2/3 4 times 4. Okay, 4 times 4 is 16. 16 times 2 is 32 over 3. What we got with the calculus. Okay. All right, so that's the area. The area is 10 2/3 square units. All right, that was the easier case. What do we do in the second case? So here, I'm going to put that one back up for you guys to look at. I would like to finish this section today. It's not that I'm in a rush. I don't want to go against what I said, that we're not in a rush. It's just that next Wednesday and Thursday are off the table. We don't get those days. So I would really like to test no later than Tuesday. And if I don't finish today and I have to finish this tomorrow, and then Monday we have only one day to review for Tuesday, see what I'm doing? I'm planning ahead. So I want to be careful with that. Okay, so as you're looking at B, I am writing it down. Y is greater than or equal to x squared. That one opens up. I'm going to do that little drawing for myself that it opens up. And start graphing, sketching. Sketch the graph. Okay, there we go. I have it up here. See, I made a little, it opens up because A is positive. Okay, I'm going to do a little sketch here. Okay. Remember, you're trying to find B and H to just plug it in. All right, so I have Y is 1, 2, 3. I have this. This is Y is less than or equal to 3. That's that horizontal line. This is the x-axis, this is the y-axis. Okay, and now I have 1, 2, 3, 4, 5. -5 is my y-intercept because of that. When x is 0, these are gone, and you're just left with -5. Okay. How about the vertex? Right? Where's the vertex? -b. So watch this. -4 over 2 times 1. So it's going to be 2 again. So that's my x-coordinate of the vertex is 2. Okay, V2. Plug it in. You get 4 minus 8 again. -4 minus 5 is -9. Okay, I need more here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 2, -9. 2, -9. Okay, and then I can go, since 2 is the axis of symmetry here, this point is 2 away, so 2 away will do a reflection, like geometry. And then now I'll probably want my roots. Okay, so my roots will be when y is 0, so good practice again. Here we go, 0, x squared minus 4x minus 5. That's going to factor into x minus 5, x plus 1. So you get x is 5 and -1. Great. Here's a root. 1, 2, 3, 4. Here's a root. Okay. But what that doesn't do is it doesn't tell me where it's going to intersect this line. This is a terrible drawing.
You could set it equal to 3.
So I am looking for the area here. Okay, so I still need this distance here. Okay, and I already know my h. What's my h? It's from +3 down to -9, 12. So h is 12. I just need to get my b. My b is this distance. So I need to know where these locations are. So how would you do that? Plug in what happened. Where is this when y is 3? You're going to get 2 answers when
Why?
Never mind.
right? Y is 3. you should get 2 solutions. Okay, so when y is 3, here we go. Y is 3 equals x squared minus 4x minus 5. What did I do? I took my original and I plugged in y is 3. Subtract that 3. That is how you're translating it, by the way. When you're subtracting 3 from the y, what is that doing? You're bringing this thing down, and then you're solving as if this is the x-axis. That is what I was talking about. That is in the math, how it's taking care of that. Okay? Now, this math doesn't know that there used to be a 3 there. It's just transformed. It's just translated down. Okay? All right. Now, that I don't think factors nicely, does it? No. Okay? So then we go x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals 4 plus or minus, here we go, 16 plus 32 is 48 over 2. Okay, that is 16 times 3, so 4 root 3. 4 plus or minus 4 root 3 over 2. And then finally,
So 2 root 3, but you're going to have to double it.
hold on. Okay, so this will be 2 plus or minus 2 root 3. So what does that mean? From the axis of symmetry, which is x equals 2, you see that in the quadratic, if you didn't know that? X equals, the first part is the x equals 2 axis of symmetry.
And if I use the
Plus or
component,
minus means one of them is plus from there, and the other one is minus from there. So the b distance is 2 times what? Not the 2. It's just 2 times this distance, this absolute value. See that? Because 2 is your starting line. Okay? This doesn't talk about your horizontal value. Okay? X equals 2 is where your center is. Then you want to stretch out equally in both directions the same amount, right? That's what equally means. Okay? So plus 2 root 3 minus 2 root 3. So the distance is 2 times 2 root 3. So my b is 4 root 3. And I'm ready to go now. So now I can plug it in. A is equal to 2/3. B, 4 root 3.
Mr. Rosendahl, why did you make it equal to 3 in the first place?
Because I look at this where it's a system of equations, right? This y equals 3, or y is less than or equal to 3 is this line. Where does it intersect the parabola? The coordinate for y is 3 at this point on the parabola. Remember what a solution to a parabola is. It's a point on the parabola that satisfies the equation for the parabola.
Okay.
So it's y is 3 in both of these locations. Okay? All right?
Thank you.
All right? And so this is what the x coordinate is when y is 3. How did I know? I plugged in 3 for y, and then I solved for x. So this is what these are the 2 x's that go with y is 3. This one is at 2 plus 2 root 3 is the x coordinate, and the y coordinate is 3. And then there's 2 minus 2 root 3 over from there, and then up 3. Those are your 2, that's where those 2 points are located. That's where this line intersects that. Okay? But I need to know this distance, and there I have it, is 4 root 3. Okay, so this 3 cancels out with the 12, so I get 4 times 4 is 16, times 2 is 32. 32 root 3 is my area, square units. Okay, that was great. There are so many, you had to pull together so many things, and then there's so many things in here, like the integral, that you get to connect that to later on. So this was a very good problem. I liked it, in my opinion.
me too.
Whatever it is that makes a good problem. Okay. Let's move on. We're going to do our last section, folks. All right. Of course, I can't tell you when the test is. What you know is more important is when we finish this, we do a review. When we finish the review, there is a test. Okay. Plain and simple. it's probably going to be your last opportunity to have an assessment. It might not be your last opportunity for a homework, but it might be your last opportunity for an assessment. Oh, I'm giving you the solution. Okay, that's fine. Example 1, write a quadratic function for the parabola shown. Okay, so you can see how they're telling you to start it out. All right, so this is the last piece, and on your test, you're gonna get this. They give you the graph. Can you write the equation? Okay, so there's your graph. See if you can write the equation. Don't look at the hints. See if you can, you know what the points of interest are, right? They're giving you a point on the parabola, 3, 2. They're telling you what the vertex is. It's kind of like point slope form. They're giving you a point and they're giving you the vertex. You should be able to get the rest and make your equation. Go. And
It's like the point slope form, except there's only a point. Only 2 points, that is.
They're giving you the vertex and they're giving you a point. So with the vertex and a point, they're saying that you can get the equation for the parabola. Although, when we started this chapter, we said that 3 points determine a parabola. But I'm wondering if you have specific points, like a vertex, if you only need 2. I don't know. Okay. So we have vertex is at 1, -2. And we have a point on it, 3, 2. Point P. Looks like you're going to be solving for A, is what you're going to be doing. Okay. So you.
No, actually,
A.
Mr. Oscar, I don't think an A would be necessary, because if you remove the A and you just make it x minus 1 squared minus 2, you plug in 3, you get 2.
Say that again.
If you plug in 3 for just x minus 1 squared minus 2 without an A, you would receive 2, as would be expected from the point that they gave you.
If you plug in, one more time, if you plug in what for what? Plug
If
in
you
3
yeah,
for x,
yes.
okay, which is
And
what I'm about to do.
no, yeah, assuming there is no A, you receive the correct answer. Well,
That's only because A is going to come out to 1 in this case. That's why it's the same. Okay,
yeah, that's the.
but if it's not 1, then you're going to be in trouble. Okay, now look, everybody. You have 4 pieces of data. All right? How many variables are in this vertex form? 1, 2, 3, 4, 5. They're giving you 4 out of 5 pieces of data. All you have to do is recognize which one's which. Okay, well, at the vertex, this is your H. This is your K. This is a point on the parabola, so this is some X that goes with that Y. Okay, so there you go. Y of 2. Oh, I think I'm done with green here. I have another green. Ah. A, I don't know.
It's a standard parabola.
The X that goes with that Y is 3. H is 1 here.
It's a standard parabola.
Be careful with the H. It's minus H. So if it's negative here, it's minus minus. Okay, plus K would be -2. Now you just solve for A. So here we go. 2 is equal to A times, this is 2 squared is 4. So we have 4A minus 2. Add 2. A is 1. Now you rewrite. Y, you leave it Y. A is 1, you don't need it. X, you leave X. H, you keep. X minus 1 squared minus 2. There you go. There's your equation. All right, if you want to put it in standard form, all you do is you expand the binomial. You just square the binomial and simplify with your constant at the end, with the constant here. And then you'll have it in standard form if you would like. but this is fine here. Questions about how to do this problem. This is what I'm looking for on the test. So basically, in this case, where they give you the vertex and some point, you're solving for A, and then you're plugging in the A. You're leaving X and Y, X and Y. Why do we leave X and Y, X and Y? Why does the vertex actually have numbers there? Is it random? No. X and Y represent an infinite amount of points along the parabola, but the vertex never changes. Just like with linear equations, when you're doing point slope, there are certain things that don't change. The slope doesn't change, so A is not going to change, okay? And the y-intercept doesn't change. Where the line crosses doesn't change. That's a constant. Same thing here. The vertex doesn't change. So
It's just the way you express it.
The h and the k don't change for a parabola, but the points along the parabola they vary. So you need variables to represent all the points along the parabola. But the h and the k here are constant. You need numbers, and the a is constant, so you need a number. That's the justification.
So actually, not for all parabolas, but just for this one, in vertex form, h is 1 and k is -2, and then in standard form, b is -2 and c is -1, like in the vertex form.
In vertex form?
Yeah,
Vertex form.
I know, but in standard form, it's the same values.
Oh, okay. Thanks. Well, I have not been looking at the chat. I need to look at the chat. Let's see. Is there any question in the chat here? Oh,
Nope.
It's in everyone chat.
Oh, host only.
Yeah.
It's because I'm doing those meetings at night. I have the 6th and the 7th grade meeting tonight.
Yeah.
So then the settings don't change. I wish that they would go back. They don't. Okay, so now I had no idea what you guys were talking about in there. I just want you guys to pay attention. I see that's the thing. I'm torn because I want you guys to have that social engagement. You know, that's what we're really missing. All right, but it's at what cost though? At the cost of losing what we're trying to do in here.
Math is better.
They're just two different things. They're
Somehow
not.
I don't
It's apples and oranges. Okay, now look at
But
what
of
they're
apples and oranges are better.
Intercept form. Okay,
Yeah.
so listen, when they give you the roots, see the other one they gave you vertex. So guess what? Vertex form. Look at this one. The graph gives you the roots. Guess what you should think on a test?
Intercept form.
Intercept form. Go ahead and use intercept form to do that. P and Q would be the roots. Oh, this green is harder to erase. Talk about trade-offs.
Probably better that we can read it though, right?
Yeah. So you're just making the case for one of the sides though. It's just so one-sided what you're saying.
We're not the ones who have to erase it though.
It's true. Yes. Now, okay. Now you're thinking like an economist. My professor at UCLA, for one of my economics professors, this really stuck with me. And I've told you guys this before, I think. Whereas in politics, you take a side. On the left hand, you have this way, and on the right hand, you have an economist. A true economist doesn't do that. A true economist says, well, on one hand, this is what you get when you go this way. But on the other hand, this is what you get when you go that way. And it's always about trade-offs and costs and benefit analysis. It's never, this is the right way and the wrong way. It's, this is the reality when you choose that. These are pros and cons of this choice. These are pros and cons of that choice. So it's not a taking sides things. It's not a value placed on things like this one's better than this one. It just depends on what is valued by an individual.
You
or
don't
by
make it clear to people.
Anyway, okay. Let's see. I have a P of -1, and it doesn't matter which one's P and which one's Q. And I have a Q of 4, and I have a point 3, 2. And I don't even need the graph when I show you guys. These are the points of interest that I have. a point on the graph, and these are the two roots. Okay? And then I want to know what vertex form looks like. It's like that. So again, what do you have here? You have an X, a Y, a P, and a Q. You have 4 out of 5 variables. Okay, start plugging them in. 2 is equal to A, X is 3, minus P is -1. Make sure you get the minus minus. X minus, oops, not X, 3. We're plugging in a 3. Minus Q, 4. And this is not a difficult, it's not a lot of work. So this is 4. This is -1. So you get 2 is equal to -4A. So A is equal to -1/2. Plug back in. Y is equal to -1/2. X plus 1. So I'm putting the P in, and you have to put the Q in. X minus 4.
Ta-da!
Ta-da is right. Now you have it in intercept form, which is acceptable. You leave it that way. Questions?
When I did it,
This seems very light compared to all the problems we've been doing this chapter. So just so you guys know, your test is skills heavy. It's like 90% skills, 10% application. So all those
problems like
all the tricky problems we've been doing, only 10% of your test is like that or less.
the tricky problems are fun.
It's all skills. So those of you that are worried about, oh my God, the quiz was 100% application. The quiz was 100% application. The test is nearly all skill. It's not word problems. Okay?
I like word problems.
I know.
yeah,
Guess what?
yeah.
David.
How have
David,
we
it's all
spent
fun
our
and games.
how have we spent our time,
David.
folks? We have focused on the learning process. The test just becomes about, you know, what you guys want. You want your grade, and I want to make sure you have the skills, right? But what we've been spending all of our time investing is application and the problem solving. All right, so I think this is an interesting way so that we can, nothing's perfect, but it's a system in which we're all kind of getting what we want.
Okay. I have a comment on this problem.
What?
So when I did it, I decided I'll put 0 on the left side. So I subtracted 2, and I got A times -4 minus 2. And so I mistakenly did, -6A. Then I tried to divide by -6, and I got 0 equals N. I'm like, that isn't a parabola.
Oh, yeah. All right, let's go back if there aren't any questions here.
Squish it.
All right, here we go. You guys do that one. Write a quadratic function. Okay, so now they're giving you a third type
We
of
can't
problem.
see the bottom of the text.
We don't want you to. That's the solution.
We can't see half the words. Like,
What?
half
No,
the
we can see it
half of
fine,
the
David.
words.
We can see
You
it
can
fine.
see it. Write a quadratic function in standard form
Oh,
for the parabola that passes through the 3 points. So when it's just 3 points, 3 x and y's, 3 xy pairs, that's where it goes back to 3 points determine a parabola. Okay? So they're saying that if you have these 3 points, they're not telling you that one of them's a vertex. They're not giving you any roots. They're just giving you 3 points that lie on the parabola. They're saying you should be able to write the equation. So go try and do that. You have to really think about what you know about parabolas and points of interest and things like that. I wonder how you guys are going to go about doing this problem. Now, they do tell you it's in standard form, so hint, hint, you probably are going to be using standard form to do this. You don't have a vertex to plug anything into, so you're not going to get any H's and K's here. So that you're not going to be able to do that. You don't have any P's and Q's. You're not going to be able to use that. So it looks like you're gonna have to find A, B, and C. Just to shove you off there. Your goal is to find A, B, and C.
Oh, you could already say you already know what C is, though, right? Just from
Do
looking.
you? Oh, you do. Look, they gave you 0, -4. That was
They gave you the y-intercept.
they sure did. Okay, I'm going to cut to my screen. So this is all you're going to need is this, the 3 points and the standard form. And I'll give you more time to try to work it out. You're trying to find A, B, and C. As Søren said, when x is 0, these are gone, right? And they're saying when x is 0, y is equal to -4. Well, that's it then. C must be -4. So you can put that right away. What if they didn't give you that point, though? How would you have found C?
I don't know. Actually, I would have. Actually, I don't know. I don't know.
Hint. System of equations.
I hate system equations.
And
I totally wouldn't do that.
This system of equations is going to have 3 variables in it. And that's the thing. This chapter comes after chapter 3, which did matrices. And so they used matrices to solve systems of equations that had 3 equations with 3 variables. But you
If
don't
only you
need,
had taught us.
you don't need matrices to do that. You can use all the skills you already know for systems of equations. Okay, I'm going to try to get you started here. Plug in your first point. -3. And I guess you can have C as -4 if you want. But that's it's not going to help you do other problems if we do that. If you didn't have that 1 point. So let's not even use that. Let's see if we can do it without that. A, and then x is -1. B, x is -1. C. Okay, so then what do I get? I get -3 is equal to A minus B plus C. This is one of my equations.
That came out pretty well. I mean, it's not like a huge.
Yeah, I mean, they're not trying to hurt you on this first one here. Okay, next, go and plug this point in. But we know what's going to happen. You're going to get, when you plug this point in.
-4 is equal to C.
Yeah, you're going to get, this one is, when you plug this point in, you're going to get -4, A times 0 squared plus B times 0 plus C. And you just get C is equal to -4. This is your second equation. So they made it easy for you. But it could have ended up something like this, where you still have the A, B, and the C in it. I wish they would have, so that we could go over that. But probably in the practice problems they will. Okay, last point. We're going to plug in the 2, 6. So y is 6. A, x is 2 squared plus b, x is 2 plus c. 6 equals 4a plus 2b plus c. And I'm going to leave that like that. I have 3 equations.
Stressed though, you're not willing to plug in C yet?
I want to show everybody I have 3 equations with 3 unknowns. So you would solve the system of equations. You have enough information. If you have 3 equations with 3 unknowns, then you can solve for the unknowns. Okay, so let's do that. Now is where I'm going to plug in the C.
I'm going around in circles.
So I'm going to have, if I plug in C is -4 here, and then I add 4 to both sides, I'm going to get A minus B is equal to 1. And then for the pink one, if C is -4, and I add that 4 here, I'm going to get 4A plus 2B is equal to 10.
Divide both sides by 2.
Yep, let's do that. So I'm going to divide both sides by 2. I'm going to take that over here, and I'm going to get 2A plus B is equal to 5. And I'm going to take this one over above it, because I'm going to solve by elimination.
Why by elimination, Mr. Rosenthal? This
Because
is
you have
literally
opposite-
textbook
Elimination best.
because you have
makes sense,
opposite.
but-
You have B already in opposites.
But
So-
this is a textbook substitution problem. You could do
This is a
as
textbook elimination problem.
Oh,
Look, B and negative B, if you add these,
3a equals 6.
you
A
get
equals 2.
3A equals 6. A is equal to 2. If A is equal to 2, plug it back in, B is 1. And C we already know is negative 4. And now we have it. Now your equation. Y
yay.
is equal to 2x.
Algebraically rearrange it so it's so for each variable rather than putting them underneath each other.
What do you mean? Say that again?
Like set it so that's like for the first problem that A is equal to negative B plus C plus 3. And then you plug that into one final equation.
You're welcome to use substitution however you want to do it. Okay?
Elimination in this way is more quick and efficient.
Once you get your system, what is the first thing I did? I got these boxes, right? Once you get there, you solve the system whichever way you see fit. Okay? And we can work on it. Any questions about this process?
Get B is
Oh,
equal to
by the way, obviously this one's the most work. When they just give you 3 points, that's the most work. Go ahead, question.
how did we get B is equal to 1?
Once I found A, I went here and I plugged in 2. 2 minus what is 1?
Oh, okay.
Yeah, 1. 2 minus 1. B must be 1. And once I had A, B, and C, I plugged them in. Got my equation.
Wait, Mr. Rosenthal, why didn't you just plug in C?
I did. I wanted to show you guys first because many times C is not going to be found right away. So the first step should be finding these 3 separate equations, then deal with the system. I don't want to teach you guys to avoid the system in the beginning because in other problems you won't be able to. So I'm just preparing you that you might have 3 equations that look like this with A, B, and C in it.
Where did you substitute the
For C,
4?
here in black, see in black, here in black. I substituted negative 4 and added it to the negative 3 to get a 1.
Okay.
And then in pink, I did the same. I added 4 to the 6 to get 10.
And then just divided by 2.
I set them both up so that these are on the left-hand side above each other so that I could use elimination.
Okay.
Okay? I'm getting a vibe, Søren, that you feel like elimination is, I don't know, just not a,
Karen doesn't like
it's not an elegant, it's like you feel like that's not an elegant method.
Well, I
not
don't
professional.
particularly like it. Although to acknowledge it is a source of quite a few errors, though I would believe not as many as elimination. Yes, I do think that I do think the substitution is much more elegant if you're going to put it that way, because it's definitely aesthetically better.
Not nice. I mean, I guess.
Yeah, did you take any surveys or data on that?
I mean, in my opinion, I actually think the substitution is. I mean, to me, I think the substitution is the superior way as well. But I'm fine with both.
I love
If I had a
elimination.
preference of the substitution.
Elimination, it just, to me, it looks so much better.
Let me
Yeah,
tell you
it
something.
looks more-
No, it looks
If we
way.
had
Honestly.
hey, listen, folks.
Worse.
Listen. If we had time to do matrices, you would have seen that's all elimination.
Yeah, but well, yeah, you could say using matrices would be even more beautiful, but I still think that if you do regular elimination, adding the equations, not as beautiful as substitution.
All right, folks. Let me look and see how much further this goes. We have an application problem, and then let's see. Follow up on application, and then the homework. So okay, so fine. Then we get to just practice a little bit here. I'm not going to do
Can't
all of
trust
these.
it.
No.
Let's do. Everybody do number 2. Can you erase the board more quietly, Mr. Rosenthal? Yes, I'm sorry. Number 2. Vertex. Okay, there it is. Be careful what you're plugging in. Done. I can take questions.
Can you wait a sec, please?
Wait, so you could just leave it in vertex form, right?
Yes.
Okay.
Any questions?
Oh,
All right. You guys are going to do number 3 now.
yay.
And that's going to be with intercepts. Okay, there you go. Once you have this, you got to get that formula down. Take good notes, folks, because these little notes you get to use on the test. Your equations for the vertex form, for intercept form, standard form, all the little tricks that we're doing. You need to compile a kind of like a cheat sheet of what you're going to do when you get the problem so that you can go quickly and accurately through the problem, not just accurately. You guys, time might be an issue. Okay, so you're going to have to know it, not just know it, but know it well enough to move through at a decent pace. You can't be stuck there staring at problems for a long time. You're going to
Will
end up,
most of the problems be like this, Mr. Rosenthal?
you'll see. Okay. You should be writing out this. A, x minus p, x minus q. Okay. 2 is equal to a, 6 plus 2, 6 minus 5. Two equal to a times 8 times 1. A is equal to 1/4. So then y is equal to 1/4 x plus 2 x minus 5.
Y equals 1/4 x squared minus 2/4 x minus 2 into 1/2.
Okay. Questions?
No.
I have 100 gigs left, please no, from Ben. What does that mean? Oh, you guys
No,
were talking about other stuff. Does it
Yeah.
matter if we use the vertex point or the point the parabola passes through? Yeah, if you have a vertex point, that's your h and your k, not your x and your y. Okay? And then the point that it passes through, you are using the x and the y from that point to substitute. So you definitely don't want to substitute the h and the k in for the x and the y. Got that, Natalie? Okay. All right. Any questions?
No, just one thing. It's an observation. It's interesting how it's such a small fraction of the 57 people that are attending. Such a small fraction of them are actually saying anything. I mean, if this were a physical class, most of the
I'm
physical
saying
classes we
something.
had, yeah, I know you're part of the small fraction. Most of the physical in most of the physical classes, just about half or more of the class would participate regularly. But now that we've transferred to Zoom format, I've noticed that very, very few people are actually participating.
Because Zoom just sucks.
Most might add, yeah. Well,
It
perhaps.
has to do with a few things that I can speculate. Bigger audience. When you're seeing everybody in the room and you kind of know everybody and trust everybody, then you feel more comfortable speaking in front of your friends. But when you have people that you don't really know that well, or it's, there's 60 people there that you don't, it creates more fear, I suppose. All right, anyway.
Fear of what?
One
There
could
are
also say that,
classmates.
like,
Fear
it's
of
like-
judgments. Is there any other fear?
it's slightly daunting to be surrounded by so many superior intellects.
How many fears are there? There's
A lot, like a lot.
fear of physical danger and probably fear of judgment. Okay, here we
So,
go.
Sir, and you and David answer everything before they can, so they don't.
Yeah,
need
I mean, we've been pretty much bullied out of being able to answer.
Oh,
Yeah, David, you always say the answer before anyone else. So
okay. Well,
No.
they can take that constructive criticism.
Right, like I'll say, back in a physical class, I tried to participate as often as possible, but I'll say that like online, I don't feel as if I can keep up with
David.
other intellects in this class, and so it becomes almost like we're bullied out of answering, if that makes sense.
I
Yeah,
won't say
it does. It
bullying,
makes
but-
sense. Bullied
Bullied is
more of a-
definitely the incorrect use of words, but
yeah,
like
yeah.
it's all I can think of at the moment.
Yeah, it's in place of right. I get it. It means that they're answering and they're processing it, and not everybody's processing it as quickly. So, but by the time they're answering, there's nothing left for you to add to it. They've already added all that's going to be added, and so you're not getting an opportunity to. This is something that has to be discussed with the teachers as we're all getting used to this new format. I wish that I was omniscient and I knew that all these things would emerge this way. And I don't even have even hearing that, a quick answer does not come directly to mind on how to deal with that. Because again, as an economist, on the one hand, there's the negative outcome, but on the other hand, the inputs we are getting are really driving us in directions that we wouldn't get to go otherwise, that are taking us to that depth and complexity that we're looking for. So there's all sorts of things that we can learn from each other this way, and then there's the downside. So I'm not going to say better or worse, but we do want to be mindful of that criticism. Those of you that are answering quickly, you might think about that, about allowing other students time. I know you're worried that you won't get credit as the one who knows it first, and that's a part of it. You want
Definitely.
Yeah, you want people to know that you were onto it. You don't want people to think that you weren't onto it also. That's a separate idea.
Yes.
Okay, so I get that. So, but think about it in a selfless way. Maybe you can sacrifice some of that reward that you're getting, that dopamine and serotonin, your fulfillment you're getting from that, so that other people can try to throw in, you have to judge it yourself. How much time are you going to stay silent? It's like a prisoner's dilemma. Who's going to talk first? Once you allow somebody else to talk and you had the idea, you lose that opportunity. It's definitely a system that has to be figured out. Okay, anyway, go do this problem number 6. This one. What's
so
interesting is they did not give you the y-intercept. They gave you one of the x-intercepts. So this time you can't get C right away. We're going to be running low on time, just so you know.
There it is. Oh wait, are you not doing a next problem?
I'm doing number 6. This one here on the board here. Write the equation in standard form. It passes through these 3 points. I'm just plugging in the first point. If somebody, you don't have to watch what I'm doing. You could just do it yourself. But if you want to watch because you're having trouble getting started, you can watch what I'm doing. And if you don't know what I'm doing, just ask me. Speak up and say, so what is it that you're doing right now? If you want to know, I'm plugging in the first coordinate. The x is -1 here. The y is 0. And then I'm going to simplify. And I'm going to start writing these with my letters on the left-hand side. And I could change it later. I'm going to box this as my first.
Wouldn't it be positive A? Because -1 is squared.
Oh, you're right. I forgot to square that. Thank you. That would have ruined me. Thanks for saving me. I forgot to put the squared up there. Thank you, thank you. A minus B plus C equals 0. Great.
Elimination time.
I'm going to do the next one with this point. So I'm just going back into my green with the second point. And I'll try to remember to square it this time. Okay. And then I'm going to get A plus B plus C is equal to -2. Box that. You're welcome to do what I'm doing when you do it on the test. Box it. Keep it all organized in a neat fashion. Okay, I'm going to plug in my third point. I'm writing hard on the board that way because I'm trying to get the last bit of ink out of this thing. Okay, step 1 is done. Any questions so far? How do you solve a system like this? I don't know if you have, you probably don't have experience in your algebra doing 3 equations.
Well, I think first you can find the C. Like, you know, the A minus B plus C and the A plus B plus C. You can possibly use elimination.
You would end up getting A plus C.
First you need to do it with the first 2 and then do it with the equation you get.
And it's like,
This is a good one. I used to love doing these. I wanted to show my teacher that I could do a 4x4, 4 unknowns with 4 equations. I wanted to, there was just another puzzle. So it's just another layer to it. What you want to do is you want to eliminate one variable using 2 equations at a time. So let me use red and black. If I put black and red together, oh my God, they're watching Sleeping Beauty again. Jeez. Now I'm going to get orange. Watch this. I'm going to get a new equation from combining black and red. Add them. 2a, b's cancel, plus 2c is equal to -2. And I'll simplify that. Divide everything by 2. A plus c is equal to -1. I now have a new equation. It is only 2 variables. See that? Guess what I can do now? I can combine black and blue, no joke intended, or I can combine red and blue to try to, what am I going to try to eliminate when I do it though? I want it to match, no, I want it to match up with orange. I want to leave A and C available for me so that I have a regular system. So if I combine black and blue, I want to get rid of B. If I combine red and blue, I want to get rid of B. So whichever one you think is easiest to do that with, I'm going to do black and blue. So if I do black and blue, I have A minus B plus C equals 0. Okay.
Multiply
Actually,
by 2 on all sides.
another thing you could do is if you see A plus C is -1 and you see A plus C here, you can plug in -1 for the A and the C there. So then you get B minus 1 equals -2. You could use substitution is fine. Right? And you can get B right away and then you could be done with the problem. But I'm just showing you this technique here. Okay. And then I have 4A plus 2B plus C equals -15. And let's go ahead and get a green one. Okay, how are you going to do this? How are you going to get rid of B? I need to multiply everything here. 2, 2, 2, and 2 times 0 is 0. Now add 6A, these cancel, plus 3C equals -15. Divide everything by 3. 2A plus C equals -5. Now I have orange and green. I'm going to take orange. And I'm going to take green. And I have a regular system of equations that I can solve. Okay, and you can use substitution if you like. I'm going to...
I now have A and B, I believe.
I'm going to multiply by a -1 here. That's +1 now. Okay, and then I'm going to add them. I'm going to get A.
Hey, we got A.
1 +1 minus 5 is -4. I now have A. Okay. Now,
I've long since obtained A, B, and C with
now
substitution.
I can plug back in here. If A is -4, I will add 4 to -1 and get 3. C is 3.
A plus C is
Okay, and then
-1.
I can
A
plug.
plus C is -1.
Hold on. I can plug 3 and -4 to here. 3 and -4 make -1, which is what I would have gotten here anyway. Okay.
A plus C is -1.
And B is -1. So now I have, hold on, y is equal to -4x squared minus x plus 3.
Wait, Mr. Rosenthal, you know the thing where it says the elimination? How do you get to 2A? How do you get 2A?
Give me a color. Give me a color.
Green, I guess.
Here, 2A plus.
No, not that one. The other one. Yeah, that one. How do you do that?
I divided each of these by 3.
No, how do you get the 2A when in the elimination process, like on the top?
Oh, here.
Black.
I multiplied the left and the right side of the black equation by 2, so I distributed a 2.
Okay.
I did that so that I would have a -2b and a +2b, or not to be. That is the question.
Oh, in this case,
Okay, but let me just remind you that it would have been a shortcut if in orange, when I had orange here, A plus C is -1. So just put that in here. Then I would have had B plus -1 equals -2, and I could have solved for B right away.
Oh, Mr. Rosenthal, in this case, substitution was much faster.
When you substitute the orange in here?
No, just in general. Substitution for all of the equations was much faster.
But I want you to practice elimination since you don't like it so much. Okay, we're over time.
Okay.
So we're going to have to start our warm-up will be the last problem of this one. Okay, if you want to get started on the homework, it's going to be the evens. If it goes over 60 problems, it's going to be every 4th problem. Okay, You are dismissed. But listen,
Mr. Rosenthal.
after we do the warm-up, we will start the review. Now, if we finish the review tomorrow, the test will be on Monday. If we don't finish the review tomorrow, then we'll finish it on Monday. The test will be Tuesday. The test cannot be any later than Tuesday.
Thank you, Mr.
You
Rosenthal.
know. All right. Dismissed. I'll leave this up if you have any questions about this problem.
Oh, another thing too, Mr. Rosenthal, all those people that don't participate in class, they don't even say goodbye. They just leave. It's as though they're just sitting there listening
Sometimes
to
I don't
everything
say
that's being said.
goodbye. I just leave without saying goodbye.
But,
Okay, maybe, but you participate.
to lend you some perspective,
Like
not
right now.
everybody is the same. As a matter of fact, everybody's different. And the way that they go about it is comfortable to them. Right? They don't want to make their presence known. They feel more comfortable showing up, getting what they need, and moving on with their day. And they have every right to do that. So
And
we
one
don't want to pass public judgment on that course.
I'm not judging them. I'm just saying what I'm just.
Are you not?
I'm just saying an observation. No, I'm not judging them. Although I do think that it is an easily solvable problem, because really, what is there to fear?
Wait, say
Also, sir, and one thing you're not taking into account is look at what point in the year we're at, which is we're nearing the very end of the year where most students are starting to become either burnt out or are yearning for some summertime or some free time, correct? And
Okay,
they just want it to
don't
be
forget
over.
the adults as well.
Right.
Me too.
And it's like everyone's been going on all year. We've all been working really hard. And especially for us 8th graders, I mean, we're looking forward to high school. And with these stressful times and with everything that's going on, I can't see myself, sitting there waiting. And yes, once class ends, I'm going to sit to make sure I can listen to a few questions, see if I missed anything. But I don't sit there and start constantly thinking about the math that I just did. I then go and relax for a little bit because I can see myself being completely burnt out right now. I'm very much nearing the end.
Thank you.
That's a valid
Thank you for
point.
sharing that, by the way. I really appreciate that.
Yeah, of
Yes,
course.
that's a valid point.
The only way my mom keeps going.
If that's the reason, then I would understand
2 weeks
that.
left. 2 weeks left.
If that's the reason why, well, then I would understand.
Mm-hmm. You guys are doing great, by the way, all of you. You're all doing great. There's no perfect answer to all this. We just kind of take one step, and then the next day we take another. And I'm really enjoying this part of the day, by the way. I like all the problem solving. These are all new problems to me, so it's, some of you understand what that's like to get new puzzles. Sometimes you order new puzzles. You pay for
yeah.
we pay to get puzzles, right? This is free. So, free puzzles. Any questions?
Brilliant.org, so I get
I have a question.
Wait, do
Sure.
you have a subscription
So
to
for confused on the
Okay,
first,
you guys, let him ask his question, please. Go ahead.
confused on chapter 4.2 on page 11 for question 8.
Oh, can you give me the question? Actually, I have the book. I can open it up to that. So let me go. You said 4.2 in the homework, number 8. I'm going to pull that up right now.
Thank you, Mr. Osta. Have a good day. See you
You as
tomorrow.
well.
Hey, Son, are you still here or not?
Nope.
What if he answered no?
Okay.
Thank you, Mr. Rosenthal. Have a good day.
You too. Okay, number 8. It said, graph the function. Label the vertex and axis. Is that the one?
No, I think it's on the guided practice for examples 3 and 4.
Oh, got it. Okay, so let me go to examples 3 and 4, number 8. In example 4, this is the football being kicked. Okay, and so what is the maximum height of the football if the football's path can be modeled by the function? And so we'll write that down. The function that they want is y equals -0.025 x times x minus 50. What form is this in? A, x minus 0, x minus 50. Right? This is the 0 is the p, because they don't have a 0 here. You see that?
Yeah.
So when it's just x, it's x minus 0. So this is x minus p, x minus q. It's in intercept form. Okay, so what are they asking? What is the maximum height of the football? Okay, so you're looking for the vertex.
Yeah.
Right? So that point of interest is not given to you in this form. This point tells you where the roots are. It doesn't tell you where the maximum point is. So where is the maximum point? There's a couple ways to find it. You can put this into vertex form, or you can get it into standard form and find x equals negative b over 2a. So let's multiply it out and get it into standard form. So here I have y is equal to, I'm going to multiply this in here and this in here like that. I'm going to get it negative 0.025x squared. Negative times a negative is positive. And what is 0.025 times 50? I'll get my calculator. .025 times 50. 1.25 x. So when you distribute this, you get this. Okay? So if I want to know the x coordinate of the vertex, which is where the maximum height of the ball is going to be, then that's at x is equal to negative b over 2a. So then negative b over 2a, I'm going to substitute. B is 1.25. A is negative 0.025. And then it's going to be positive. Okay, so that's going to be 0.05. So 1.25 divided by 0.05. When x is 25, and in this case, I think it's x is measuring feet, not time. So it says the path, x is the horizontal distance in yards, y is the height in yards. So at 25 yards from where you kick the ball, or the kicker kicked the ball, it reaches its maximum height. But the question is, what is the maximum height? So you have to plug that in. All right, so when I plug in 25 for x, I'm going to get this. (25 minus 50 is negative 25. So I'm going to get 25 times 25 is 625 times 0.025. It comes out to positive 15.625 yards is my maximum height. Got it?
Yeah.
Okay. And I think you had another question from another page, right?
Yeah. It's on page on lesson 4.3.
And which one is that?
It's the warm up in the beginning of the lesson.
Oh, the warm up. Okay. So that was the flying fish problem?
I think it's the one. Wait. I think it's before that.
Okay. The popcorn.
Yeah. The popcorn.
Okay. Well, what did you want to know about the popcorn problem?
I just need to. I'm just confused on the answer for it.
Okay. It's a complicated problem. So it says a kernel of popcorn contains water that expands when the kernel is heated, causing it to pop. The equations below give the popping volume Y in cubic centimeters per gram of popcorn with the moisture content X as a percent of the popcorn's weight. Okay, so hot air popping, it's this equation. And this is in vertex form, or intercept form. And then for oil, hot oil, you have this equation. Okay, so that's popping it in air, popping it in oil. It follows different equations. Y is the volume at which it pops. X is the percent of water that it's reached when it pops. Okay, so for hot air popping, what moisture content maximizes popping volume? Well, you're just, again, you're getting that, you're doing what we did in the last problem. You're finding out the vertex, the maximum point of the parabola. Notice that the A is negative. Both of these do this, right? And you're measuring Y here and X like this, right? Okay. All right, so because you're doing that, to find out what the maximum Y is volume, you're looking for this point. You're looking for that point for hot air popping. It says what moisture content maximizes popping volume. Okay, well, the moisture content is X. Moisture content. This is popping volume. So you just got to keep, that's what makes the problem tricky, is remembering what stands for what. Okay, they're saying what moisture content. So they're looking for the X value at the maximum popping volume. And then they want the maximum popping volume. So they want the X and the Y here at the vertex. Well, that's the problem we just did. What you do is you multiply this out and you get it into standard form. Once it's in standard form, what do? You tell me. X is equal to what at the vertex? Negative?
Negative
B over?
Negative B over 2A.
Yeah, so once you have this in standard form, all you have to do is multiply it out. Then you have your A, B, and C, so it's just negative B over 2A. That gives you the X right underneath here. And then you plug the X in, and it gives you the Y. Okay. Letter B is the same. It asks you to do the same thing. Then you go back and you do the same thing for B. For hot oil popping, what moisture content maximizes popping volume? And what is that volume? And then letter C says, graph it. The domain and the range is what are that different, what can X be is the domain, right?
Yeah.
What can Y be? What's the maximum it can be and what's the minimum it can be? Okay, and then that's it. So this problem is actually just like the football problem. It's just multiplying it out and getting negative B over 2A for your X at that point and then plugging it in. Got it? Yes? No?
Yeah.
Okay. Were there any other problems?
Wait, so basically I just multiply it, right?
Yeah. And then it comes out to standard form when you do that.
And then use negative B2A. The equation, so once I multiply it to standard form, I use the equation negative B over 2A, right?
X equals negative B over 2A is the X coordinate of the maximum or minimum point. Then once you have the X coordinate, you plug it back in, and then you'll get a Y for that X. And then you'll know where that maximum height is.
All right.
Hi, I have a non-math related question. Is that okay?
Of course.
Okay. So over the past few weeks, I've been making like baked stuff for my friends, right? And I'll wear like gloves and masks while I bake it, and then I'll drop it off at their door. And I asked my mom, and she said I could bring my teachers like cookies on Monday. So would you want cookies?
You want to drive all the way out to Simi Valley?
No, I mean during textbook drop-off.
Oh, textbook drop-off.
Yeah.
Yeah, that would be great.
Cool.
That would
Do
be
you have any like
who am I talking to right now?
Tiella.
Tiella. Oh yeah, that would be awesome.
Okay, yay.
I don't think I ever got some of that cake you were making. You were supposed to.
You did not. Do you want me to make you a cake too?
No, do not make me a cake. I'm gonna gain the COVID-19 soon.
Yeah. I'll
Yeah,
give you
that would be great. Cookies would be great. I can share them with my kids and my wife.
Yeah, I'll give you extra because your kids are really cute.
Oh, thank you.
Of course. Okay, thank you.
You betcha. Have a great day.
You too.
Anybody else have any questions for me?
Mr. Rosenthal,
Yeah.
I have a couple questions about like imaginary numbers.
Uh-huh.
And so like I don't think I exactly understand what an imaginary number is exactly.
Let's take a look at a complex plane. If I have an X number line, let's go back to pre-algebra and basic math. There's only one number line that you learned, right?
Mm-hmm.
In the beginning, you just learned what positive numbers, right, in elementary school?
Mm-hmm.
And then you learn negative numbers, which you're fine with, I'm sure.
Mm-hmm.
And in elementary school, that was all that existed. So how did you graph a point like X equals 2? You put a point there, right?
Mm-hmm.
Okay. And what would this equation be?
X equals -2.
Uh-huh. And what would this be? Ah, what would that be?
Is that where the imaginary numbers come in?
Aha. Okay, what real number does it look like it would be if it was on the line?
3.
Oh, great. Okay. So X is equal to 3 plus there, it's not at 3, right? You don't see anything there.
Mm-hmm.
So you have to add some other value to that. How do you get it into somewhere that doesn't exist? Well, what we do is we create an imaginary axis instead of the y-axis, call it I. And we'll start counting. 1i, 2i, 3i. We're counting in some imaginary direction perpendicular to our axis. Okay?
Mm-hmm.
And so this is lined up with 2i. So there you go. There's your complex number.
How would you know where that is though?
You don't. You don't need to know. We didn't need to know where it is. We never used it as a location. It doesn't exist in a real plane. We didn't use it for that. We just did calculations with it. And when we graphed it with this understanding in an imaginary and a real axis. You don't have to understand where that is.
No, but like why 2?
How far did we go along this complex axis? What if I want the point to be here? It can't just be I. We want to be able to count how far into that imaginary that you've gone. So by numbering that, you can actually count how far you went into the imaginary space.
Oh, okay.
And treat it like y. Okay?
Okay.
Yeah.
Also, just to be sure, when you square root a negative number,
Mm-hmm.
but like it's not a perfect square, would you simplify it?
Yeah, you can do it this. Write it as 2 separate ones.
No, but like with I.
Yeah, I am. But watch. First, rewrite it like this.
Mm-hmm.
Square root of 3 is fine. This, you pull out the part that's not fine, the -1. Okay? Any negative number, you can pull out the -1. Any negative number. So you can always pull out the -1. And that we defined as I. So this is square root of 3i, which is somewhere along here. Square root of 3 is like 1.7, I think. 1.7i is like here, right?
Yeah.
2, I guess 2 would have been there. So here's where that's like right there. But I don't know what the x value is, the real value. That doesn't have any real value. If it doesn't have any real value, then guess where it is? It's on the y-axis only. It's at 0 on the x-axis. This would be 0 plus, right? I can add 0 to anything. It doesn't do anything, right?
Mm-hmm.
right? And so where would that be on the x-axis? It would be at 0, and you would come up to root 3i on the component.
Okay. And then one last question. This isn't on imaginary numbers, but I just wanted to be sure on this.
Okay.
So when you're after you factor, once you have like the two parentheses, like x minus x plus whatever, and then another one of them, would your answer, like your two solutions, would they be the 2 and the 5? 2 and the
No.
negative 5?
How do you make this 0? How do you make the equation 0 equal to 0? Either this has to be 0, and this could be anything.
Mm-hmm.
Because 0 property of multiplication says it doesn't matter what that is if that's 0. When you multiply, it's going to equal 0. Or the other way around. So what does x have to be to make this 0 is not 2, it's the opposite of 2. Negative 2. What happens if x is negative 2? You get 0. You don't get 0 here, but it doesn't matter. Now, but if I want to make this one 0, then it doesn't matter what this one is. To make this group 0, x would have to be what?
5.
Yeah, so those are your solutions.
Okay.
Okay?
Okay. Thank you.
Gotcha. Anybody else questions? All righty then. I will see you tomorrow.
Have a good day, Mr. Rosenthal.
You as well. See you tomorrow.